Aber auf Strecke. Immer das Null fast das Gleiche. Das kommt dann rüber zu den ja, genau. Und da bin ich dort raus, habe mich so in die Zone gefühlt, da war alles still an den einen Feld, das war, glaube ich, auch wärmer. Das soll ja nicht so ruhig halten. Aber ich bin
ach, noch kühler als heute. Ja, ich
glaube, das ist nicht so gut. Ja,
das ist dann nicht wieder.
So welcome back, everybody. I think we can start with the afternoon session. And the session will be opened by Marta Piekarska from Hyperledger current use cases, which is lost today.
Yeah, for some reason, let me just try that.
Sure. As soon as you're ready, okay. Feel free to start.
Any problem?
I'm trying to switch to the VGA because the HDM.
Press the source button.
The HDMI seems to. Let's see if that is more stable. So hi everyone, my name is Marta Piekarska. I am Director of Ecosystem for Hyperledger, and I'm going to talk a bit about what is Hyperledger, what is Linux Foundation, to give you an update on that, and then we'll dive more into the frameworks. I have a PhD in computer science and user-informed design of privacy tools. I've been in various companies in parallel to my PhD, and for the last 4 years I've been in blockchain space. They say that you should count blockchain years as donkey years, so I guess I've been there for like 40 years or something. Let's start with the basics, which is that Linux Foundation is much more than Linux. It is a common misconception that Linux Foundation was founded it exists to sustain core Linux. It does, but we've been formed 16 years ago to provide the governance, legal, marketing and PR infrastructures to create the world's biggest shared knowledge on open source. We started off with core Linux, but it turned out that this scales very well. Bringing enterprises together to build open source frameworks is something that can be scaled to any major industry. So today we have over 50 different projects, and I'm sure some of them you know. How many of you have heard about Node.js? Yeah. Or Kubernetes is another one that is pretty big. So these are the big projects, but also we have projects that are much less famous or known, like Let's Encrypt is probably fairly well known. Automotive grade Linux is one that not that many people know of. About 2 years ago, we have started being asked, have you heard about this thing called Bitcoin? And we said, yeah, we do read newspapers. People were like, well, why don't you do a project on that? Our executive director, together with some of our enterprise members, said, you know what? Bitcoin is not something that really helps advance the mission of the Linux Foundation, which is promoting open source and bringing enterprises together to build on top of open source frameworks. However, the underlying technology for which Bitcoin is a great use case is very interesting, and we should do something about it. And that's how Hyperledger was started. Hyperledger was started to build the governance infrastructure and the kind of collaborative community to bring enterprises and open source developers together and advance various industries with blockchain. Specifically, we focused on permission blockchain and not anything else. Since we've launched, we've been 2 years ago, we've had 47,000 commits of code. We've grew from 2 different frameworks to 5 frameworks and 5 tools, and I'll talk a bit more about that in a second. We have 2 production releases, Hyperledger Fabric and Hyperledger Salted are in production version or deployment ready version. And we've grown from 30 members to 250. Quite often I'm asking, who are the members? Some of the companies that are members of Hyperledger, including Daimler, who I know that you've heard from earlier today. And many others. This is the list of general members. We also have an associate level membership, which is interesting because it also reaches the academic program. So we welcome universities and researchers that want to work on Hyperledger and prove to us that we are wrong and our code is wrong. We want to work with you guys, and we want to hear from you and help you develop. So, as I mentioned, Hyperledger is a collaborative project under the Linux Foundation, and we kind of provide the neutral home for collaboration and legal services, marketing and PR, developer and vendor coordination. That's one of my roles, to kind of help people talk about blockchain. We have a greenhouse approach. So our idea is that anyone can come and seed their idea into our greenhouse, and if the community wants to foster the plants of ideas and they will bloom to something beautiful, that's cool. But if also the community does not feel like taking up a project or doing something, usually the answer is, well, no one wants to do it, so probably we shouldn't be doing it. So some ideas will naturally die. However, we don't think that there is one blockchain, there will be one blockchain to rule them all. There is a spectrum of blockchain technologies that should be applied to various industries and various problems. And depending on the industry, there will be different approaches necessary. So today we have Hyperledger Borrow, Hyperledger Fabric, Hyperledger Indie, Hyperledger Iraha, and Hyperledger Salted. That are all 5 frameworks that provide kind of the piping, if you will. It's not that there are any applications built within Hyperledger. That's what our members do. They take those frameworks and build on top of them. In Hyperledger, we work only on the framework side. We also have tools, Caliper, Cello, Composer, Explorer, and Quilt, which are all tools that allow you to deploy, develop, and work on different projects. So Hyperledger Composer is a tool that allows you to deploy your own blockchain network. It is a very nice UI that kind of, even if you're not a specialist in blockchain, you can take and build with it and deploy your Hyperledger Fabric framework. We have Hyperledger Cello and Explorer, which are two tools that allow you to kind of inspect what is happening on your network, both on blockchain side and on transaction side. Hyperledger Caliper is our framework that is focused on performance testing and kind of benchmarking of different deployments. It is not there to compare frameworks as such, because depending on the deployment, the numbers will be different and the use cases will be different. But it's more about worst case scenario, how does my deployment work? Or best case scenario as well. And Hyperledger Quilt is the interledger protocol, the one that Ripple is kind of got famous for. So that protocol and implementation of it in Java. So as I mentioned, there is a spectrum of blockchains, and there is the kind of permissionless public network that is great and is very well used by Bitcoin and Ethereum community. And it is very useful, and it's there for cryptocurrency purposes mostly. Then we have the other side of that spectrum is permissioned private network, where you focus more on instances where you don't necessarily want everyone to read or everyone to write to that network. So it's kind of, the permissioning system could be seen as the accessibility right? So who can join the network. And then the public versus private, I would see it as visibility aspect of it. So who can read from a blockchain network. And I think that in that space, if you think of medical records, for instance, it doesn't make sense to hold medical records on a public network or permissionless network, because of course we want to limit the people who can write or to your medical records, and doctors submitting a disease or a test that they've done to you makes sense, but I don't want a random person to just add a bit of hepatitis C to my medical records just because they don't like me, right? And also similarly, I shouldn't be comfortable with revealing my medical records to any random person. I should be able to control my medical records. And then there's the middle space, right? So if you think of certification, like university degrees or land titles, you want a permissioned public network, so that only your university can, or your professors can issue some degrees or your blockchain. But anyone should be able to verify that I have or have not received a PhD in computer science from TU Berlin. And then there's the permissionless private network, which is probably the one that is least occupied, and there are least applications of that one. I think public polls could be something that could be interesting aspect. But yeah, so that is kind of how we see that spectrum of visibility and accessibility. It could be a grid more than probably a line like that. So as I mentioned, our vision is that there won't be one global blockchain to rule them all. I don't think that anyone in Hyperledger, you hear anyone in Hyperledger saying, Ethereum will die, or Bitcoin will die, and it will only be about Hyperledger, or Corda will rule the world, or whatever else. I think that there is a spectrum, and that spectrum is more about how do industries develop and adopt a blockchain, and where are the use cases that should be occupied. So let's dive a bit deeper into our frameworks, as I've mentioned that word several times, to kind of differentiate several things. So Hyperledger Fabric is a blockchain that has probably been the most mature one. It is written in Go, It utilizes smart contracts mechanism. Natively, it's chain code. That's the language in which it's written, and chain code smart contracts are executed in a Docker container. On the other hand, since 1.2, which will be released very soon, we will also be supporting Solidity smart contracts. So you'll have a choice of what smart contracts you're using. The ordering of nodes can be separated from broader endorsers and submitter nodes, so you have different roles on the network. They all can be the same ones, but they also can be separate. Interestingly, there are also concepts of private channels that allow for a subset of the ledger groups, or subset of the ledger for groups of nodes for confidentiality. So if you want to prove a provenance of information but not necessarily reveal the content of that transaction, that's where you use private channels.
Marta, the chain code is the secure?
No.
The smart contracts?
Yeah, chain code is smart contracts, yeah.
And then the Docker container is then included in the blockchain?
Yeah.
Oh, okay. Thank you.
It's actually both Hyperledger Fabric and Hyperledger Sawtooth allow for pluggable consensus, which is an interesting concept where you can change the consensus mechanism on the go. So you don't have to destroy your network and start it again. You can actually, on your network, use several consensus mechanisms depending on the set of transactions. Hyperledger Fabric uses Kafka as consensus mostly. So it's pluggable, but by default it's Kafka, which is a crash fault tolerant consensus. Then we have Hyperledger Sawtooth, which is slightly less mature, although it was one of the two initial projects, so one of the two founding projects. And it supports both permissioned and permissionless deployments, although we haven't seen actual implementations of the permissionless system. So architecture allows for it, but no one has yet implemented it. It is, as I said, it supports pluggable consensus, but by default it runs on proof of elapsed time, which is basically the public properties of proof of work without the energy consumption. It does require a secure enclave on a chip. Today it's only implemented through Intel's SGX chips, where POET is executed. It does not, but theoretically and practically, it could also run on Trust Zone and on ARM chips. It's just that nobody has attempted to implement that. Proof of elapsed time is a concept where you compete to get the least execution time in the trusted execution environment to exit, and the person who gets, or entity which gets the least time is the one that will be able to add a new block to the blockchain. It supports on-chain configuration tracking and, as I said, the consensus mechanism switch, and uses Solidity and Ethereum virtual machine as smart contracts. Hyperledger Indy is our identity blockchain that works on it was contributed originally by Sovereign and Evergreen Foundation, and it really focuses on identifiers that are rooted on blockchain and provides pairs of distributed identifiers that are only revealable by the user for FIDO-ability. It utilizes zero-knowledge proofs and to provide verifiable claims. And the concept is to store all of the private or personally identifiable information off-chain, not on-chain, because you don't want to encrypt data and put it on blockchain, because obviously for immutability, if we say that blockchain is immutable and encryption gets broken, then you're kind of in the rabbit hole. You don't want that. You want to store it off-chain so that it's more secure and if encryption gets broken, you can re-encrypt it with a new key, and that information is not accessible on the chain. Obviously, you know how zero-knowledge proofs work. You can provide proof that you have an information or you have a certain property without revealing what the property is or what is the precise information. In production today, it is used on the sovereign network with the credit unions and GSA being the main kind of user of that. Then we have Hyperledger IRAHA, which is a business blockchain framework that is developed mostly in Asia, and it is very close to 1.0 release. It is written in C++ for a very tight memory control, and it runs on IoT, mobile devices. It has very big emphasis on mobile applications, and provides both Android and iOS SDK, so if you want to play around with that, you can. So what these frameworks differ from, how do they differ, is by the consensus mechanism and the governance model. And consensus, is a process by which a network node provides guaranteed ordering of transactions and validates the blocks of transactions. And the core functionalities is that a good consensus should have is confirmation of the correctness of all transactions, agreeing on the order and correctness, and then interfacing on smart contract layer to verify that correction. I think that what makes a good consensus is a decentralized governance, integrity, non-repudiation, privacy, fault tolerant, and performance. And there are different consensus mechanisms, but in order to have one that is reliable, it has to fulfill those properties. It may do it in different ways, but these are the core properties. So of course, we have the various consensus mechanisms. We have two standard approaches, which is the lottery-based and voting-based, and each approach targets a different network requirement and fault-tolerant model. So in lottery-based algorithms, they have the advantage that they can scale very well to a large number of nodes, since the winner of the lottery proposes a block and transmits it to the rest of the network for validation. So you can build it out very well and quickly. On the other hand, these algorithms may lead to forking when winners proposes a block and the network does not accept it. So each fork must be resolved in that case, which ends up with a longer reconciliation time or longer time to finality. On voting-based algorithms, they have very low latency of finality. It's very quick. Because when the majority of nodes validates a transaction or a block, the consensus exists and finality occurs. So it's a very fast one. Because voting-based algorithms typically require nodes to transfer messages to each of the other networks, they don't scale as well. Because you have to all of a sudden transfer a lot of information on the network. So there are ups or pluses and minuses of every consensus mechanism. The standard situation in Hyperledger or the standard transaction flow is fairly simple, which is, the client delivers the transactions to a pending poll, and then the transactions are selected from the pending poll, sent for application, and speculatively applied the transaction through the smart contract mechanism, and then they return a proof of correctness or a change set. That's also the case, sometimes the case. And if a transaction has been successfully applied, they get ordered, and that's part of the consensus mechanism. and broadcasted ordered list of transactions is sent with the proof of correctness and the change set to the other peers. This whole thing then also gets on the smart contract layer, we get requests and verification of transactions. Most of the consensus and governance models in Hyperledger separate the validating peers and the broadcasting peers. And there are, at this stage, we also have conflict resolution. Finally, we commit block of transactions and notify clients of events that there has been a new block. In Hyperledger, we have, as I mentioned, several consensus mechanisms. Each framework basically has a different one. So Hyperledger Fabric has a permission and voting based mechanism where leader does the ordering. And only in-sync replicas can be voted as the leader. In Hyperledger Sorted, the pluggable election is set to a permission lottery-based strategy by default. On Hyperledger Indy, the election strategy is set to a permission voting-based strategy by default called plenum, and all instances of the ordering, all instances do the ordering, so not just the leader. But only the requests ordered by the master instance are actually executed. They have different kind of benefits. The poet provides really good scalability, and in terms of Indy, the finality happens in a matter of seconds. So is Fabric. So this is really good. But on the other side, in Indy, the more nodes exist on the network, the more time it takes to reach that system, because it's a voting-based system. Yeah, I'm going to skip those slides because I see that I'm running a bit out of time, but they will be available. So you can read a bit more about the differences between Hyperledger Fabric consensus, where you have three phases. There's an endorsement phase that is driven by the policy, ordering phase where you accept the endorsed transactions and agree to order, and then validation where you take a block of ordered transaction and validate the correctness of the results. In Sawtooth, it has a pluggable consensus, as I mentioned, and by default it is uses POET. It's very fair. The cost of controlling the leader election is proportional to the value gained from it, and it's verifiable, so it relatively simply allows for verification that the ledger was legitimately selected. In Indy, the Hyperledger Indy is based on a redundant Byzantine fault-tolerant system, where the protocol is inspired by the plenum Byzantine fault tolerance. And it's basically just like running several instances of plenum in parallel. That's what Indy's code is. On the ordered requests from a single instance that are called the master is used to update the ledger, but the master's performance in terms of throughput and latency is compared periodically to the average performance of other instances, and if it's not performing as well, then the view change occurs that appoints a different instance of the raw master. So you choose the best performing one. Some papers that we have here are kind of, you can read about it. We also have one on smart contracts. Then if you want to catch me later, I can talk a bit more about the letters of credit and digital trade and other use case applications, because Hyperledger has been successfully deployed in several business and industry use cases. we currently know of at least 35 different deployments. I'm not talking POCs, I'm talking deployments. To skip to something that is more important for everyone, once I get my, okay, here it is. I wanted to talk a bit about the resources. So we have an edX course if you want to take it. It is at your own pace, it's really good. It takes you all the way from what is a blockchain to how to deploy Hyperledger Sawtooth and Hyperledger Fabric hands-on, like with code download and everything. We have a bug bounty program. So if you're into finding security holes, you can actually get paid for it. We have working groups if you're more into working on papers. All of this is open to public, it's open source, it's under Apache license, so it doesn't get more open than this. And importantly, we have a Hyperledger Global Forum, which is a conference that we are organizing in December in Basel. The call for paper is open for a bit less than a month, till 13th of July. So if you want to get your university to pay for you to visit Basel, submit a talk proposal, because we welcome everyone. There is a business track and there is a technical track. So either case, very much worth doing. Okay, we have 2 minutes for questions.
Right, it's my job. Where do you get the elapsed time from, Marta?
Sorry?
The elapsed time, where do you get the elapsed time from? Is it the central server?
It is selected through the, so it's a protocol that allocates it on the trusted execution environment. So it's randomly allocated to all participants.
So different members from
yeah, that wants to add a transaction, get allocated time, and the one that with the least time allocated is the one that wins the lottery and gets to submit a new
block.
block.
You don't have problems with synchronization of the blocks?
No.
Thank you. That's interesting. Thank you.
Okay.
I have a question myself. So this morning they told us that blockchains are a nightmare from a sustainability point of view. That we should all be scared and all our energy is going to that. What's your comment on that?
My comment on that is that if you're using proof of work, then yes, there was a really good article in New York Times, which the title was, "Is Bitcoin just a huge waste of energy or something worse?" I really like it. So yes, proof of work is horrible when it comes to energy consumption. We all know the statistics that today for proof of work we are using more energy every day than in a month Iceland or something like that. It's like insane.
We heard Belgium today.
Yeah. However, that's why we have other consensus mechanisms, and that's why people are investigating that. There are other ways to do it. Of course, there are several things. First of all, I strongly hold the opinion that blockchain is not a distributed database, it's a distributed record of logs or transactions. So it has to be implemented differently. Because if you want to do a distributed database, then do a distributed database, and you don't need the consensus mechanism, and you don't need several other things, and it doesn't blow up your network. So that's the big problem, that if we try to tell everyone hold a different copy or the same copy of a database that is growing, and it's immutable, it's pretty damn expensive in many ways. So in that way, that's one of the faults that people do. There are other as well. It is true that permissioned ledgers do require a certain level of governance. What we like to say is that it's a minimum viable governance. That's kind of the concept that we are using. Where you need some kind of reconciliation, but even if you think about it, DAO, right? You had a community that gathered together and had to decide what happens. Like, failures on the network happen, and you need to have a way to backtrack from it. That was a very long answer to a very short question. Anyone else, or should I give the stage to the next person? Okay, cool.
Let's thank the speaker again.
help it out if you want some nice stickers.